Alright guys, lab number 10. This one is going to be using a 3-2 to control a 5-2. The 5-2 will be controlling a double acting cylinder. Before we start, remember I said that I'm going to give you the first 10 labs and then release the hounds. So with these first 10 labs, we have now gone over the 3-2, the 5-2, the speed control, the double acting cylinder, the single acting cylinder, and the and the or valve. So we've gone through all the bits and pieces that we need in order to create harder circuits. If you've been letting your partner do each of these labs, then you're completely lost when we get into the harder circuits. Harder circuits are going to take you about half an hour to an hour to complete. If you haven't been keeping track with these first 10 labs, then you have absolutely no idea what we're doing, and then when we get into these harder labs, it's going to take you that much longer to get through. So take the time, go back over the first 10 labs, do them yourself, make sure you understand how each of the components work, and then when you get into the more complicated circuits, it'll be a lot more fun as you're trying to work through them. Next thing I want to cover is, as we build up these more complicated circuits, I want to show you the kind of the nuances to setting them up so that they're nice and clean, and you can kind of organize your thoughts and not have lines going all over the map. So let's take a look at this. Later on, we're going to look at a double acting cylinder that's being controlled by a limit switch. Most people place the limit switch up here because that's physically where it is on the board. However, when you're setting up your circuits, you want to keep everything nice and simple. So you can see that the air supply is down here. We have our filter, lubricator, and regulator over here. And then we're coming up to all of our 3-2s. So you can see that all of our 3-2s are in one line here. The limit switch that is physically placed up here is put down here so that all the 3-2s are in line. You can see this 1S3 corresponds to this 1S3 up here. Okay, so all of our 3-2s are in line. Then we have our and or valve, so our logic circuits are right here. Then we have our 5-2. And then in between the 5-2 and the double acting cylinder, we would have our speed control. If we're going to have an on delay or off delay timer, that would be going right here in between our logic and or gates and our 5-2. So timers usually go in the initiating valve of the 5-2, and then speed controls will be placed here. Okay, one more time. 3-2s and or valves, any on or off delays, 5-2s are on the line, speed control, and then double acting cylinder. You can see that it really cleans up your diagram and keeps all your lines nice and straight, and it's easier to walk through. All right, let's take a look at this circuit, guys. All right, so I've just gone ahead and grabbed all the bits and pieces that we need. We need two 3-2 push buttons. We need a 5-2 impulse valve. And we need a double acting cylinder, and we need a source of air. Okay, let's just slowly build this up. We need to provide each of these 3-2s with a source of air. Okay, we also need to provide the 5-2 with a source of air. So I'm going to grab this guy, bring that guy down. Be careful on the test when you guys are drawing this out. Invariably, you will always forget to put in the supply for the 5-2. Even when you go and hook it up in the lab, you'll be wondering why things aren't working. You've forgotten to bring your main power source up to terminal number 1 on your 5-2. Okay, each of these guys is going to then go into our initiating ports for the 5-2. And then we're just going to set this guy up like this. We'll bring our 2 lines up to our double acting cylinder, and then we can hit play and see whether everything's connected. Okay, you can see here that we have pressure going to the 3-2s here, and this one is set up so that if I hit one of these push buttons, in this case this one right here is going to control this initiating port. This initiating port will allow this position of the 5-2 to come in. Right now we have the double acting cylinder in the retracted position. If I hit this push button, then the air now travels from 1 to 2, goes to my initiating port, and now on the 5-2 I have air going from 1 to 4, pushing up on the double acting cylinder. Any air that was in here now has a clear path to go down from 2 down to 3. Okay, so you can see here that it's extended here, and all I need to do is just tap that push button and it stays in that position with full pressure still applied. So lab 3, remember, we could take this, we could physically move this back and forth. Right now there's no way we can move that because now we have the full pressure from our source going up out to 4 and it's being maintained here, right? So it's a latching or maintain circuit. Okay, it'll stay in that position until the next signal comes in to the other side of the 5-2. Okay, so as long as I have let go of this push button here, I can now press this guy, pushes it back to the initial position of the 5-2. I now have air coming up from 1 to 2, pushing back on the double acting cylinder, and the air that was in here has a path to escape from 4 down to 5. Okay, again, once I let go of this guy, it stays in that position. There's full pressure going up and keeping it retracted. So full pressure for the extend and full pressure for the retract. Excellent. So what I want you to do is write this down on a piece of paper. So you're going to slowly and methodically build this up on a piece of paper. Then you're going to come and use the fluid sim. Make sure it works on the fluid sim. Then we're going to do it into the lab. So you're physically writing it down, then you're using the fluid sim, then you're doing it in the lab. And by doing all 3 of those, you'll see how each of the components work, and you'll be able to kind of laser etch each of these circuits into your mind. Okay, let's go ahead and take a look at this in the lab. Alright guys, lab number 10. This next one we're going to make use of another 5-2 valve. We're going to make use of this guy right here. And we're going to set up a circuit where if you press the black push button, then it's going to extend this double acting cylinder. If you hit the red push button, it's going to make it retract. We tried that before, I believe, in lab number 3. But the problem with that guy was that we could actually take this and move it back and forth because the air was coming in, exhausting out of one of the switches. So now we're going to create a memory circuit in that we're going to bring air into each of these switches here. So we'll feed the black and we'll feed the red switch from our main manifold here. Okay. From there, we're now going to go into our initiating ports of this 5-2 right here. So let's see, I need to, maybe I'll do my outputs first. I need this guy right here to, let's see, I need this guy to retract, okay? And I need this guy to extend. Okay, excellent. I'm going to bring an air source into that 5-2 as well. So I'm going to feed terminal number 1. That's good. Okay, and I need this guy to now send the signal into here from the black. And that's going to cause that to extend the cylinder. But I need it to retract. I need the opposite signal coming in. So I need one more output here from the red push button. And we're going to go over to this guy right here. Okay? Again, a little bit crazy here with the lengths of the tubes, but the beauty of this is that you can see that the length of the tubes goes to any component here. So do me a favor and don't cut the tubes on me. Keep them all the same length. Let's see how this works. That's not exactly what we're looking for, but maybe we have to think about this for a few seconds. Does this guy actually have a spring? No, it doesn't have a spring because you can see the spring is here. So this 5-2 is going to stay in the position that it was left in. So whoever did the last lab had this 5-2, and the last signal to come in made this go the way that we've set it up, made this double acting cylinder extend. So let's have it retract. Oh, that's nice. As soon as we now touch one of those push buttons and tap it, it does a full cycle. Now the issue before was that I could push back on this and it would exhaust out of the other switch. I can push as hard as I can, right? Give myself a hernia here, but it will not go back. Okay? If I now retract it, I was able to pull this out. Again, I can reef on this as hard as I can, and I can't move it whatsoever. So the beauty of this now is that I can now extend it, right? Come back after a day, and it stays in that position. Okay, once I retract, it has a memory circuit, so we can turn off the circuit, turn it back on, and it stays in that position, locked in by the 5-2. we have this full pressure from the manifold going to 1, and it's either causing that air to go to extend or retract the double acting cylinder, right? So extend with the black and retract with the red. All right, guys, very cool. We're moving into some pretty cool circuits now. That's the first 10 labs. I'm going to show you a couple more, and then we're going to release the hounds. So we're going to use these first 10 to 12 labs, and then you guys are going to build up some harder labs later on. All right, guys, thank you. Move on to the next one.